Good morning, good afternoon. My name is Navin Sharma, and I'm the head of product here at Stardog. Excited to bring a topic that's top of mind for a lot of folks, especially in the context of GenAI, all about hallucinations and what we can do to help improve on that from an AI safety perspective with a very unique approach that we have taken here at Stardog. So excited to bring some of my thoughts and of course point of views, and look forward to hearing from you and your questions. And for those that do have questions, please use the Q&A channel to put in your questions. And as I go through my slides and into my demonstration, I will take a moment to look through those questions and answer as quickly as I can. So again, let's get started. So I know this topic comes up pretty much every conversation I have with large enterprise organizations that are embarking on and looking to bring GenAI into the enterprise. And one of the topics, certainly for those in regulated industries, tends to be around AI safety. But we also know clearly at this stage that every industry will look to empower their knowledge workers with AI. But the key to that enabling and empowering is going to be AI that's grounded in trusted data. And those are the companies that will be the winners in their respective industries. Of course, at the same time, we also know that many of the large enterprise organizations are certainly limited by where they are in their own data journey, in terms of data being fragmented as a challenge that they're dealing with. Data lacks meaning because it lacks context, oftentimes, especially when it gets ripped out from its source system and onto some sort of a data lake or a lake house. And then of course there's a constant struggle with skill set requirements and the cost of technology infrastructure to enable Gen AI inside of the enterprise. And we know that AI hinges on trusted enterprise knowledge, and that's critical given the era we're in and given what we're learning with this fast-moving, very exciting space in the market. But we also know that there is general anxiety about Gen AI out there in the enterprise. And it's no surprise, given what we are hearing in the news pretty much on a daily basis. This is a few of those headlines where a lawyer used the ChatGPT in court and cited fake cases to the point where the judge was actually considering sanctions. We also know that beyond hallucinations, we find that the reliance on large language models for answers tend to be static in nature, and of course generalized in that sense that it's all about general knowledge, not knowledge about your enterprise. And it's knowledge that's perhaps a little old. And this kind of brought out that point that I wanted to make with the Bing AI chatbot, where someone actually asked for movies that were playing on the weekend, which, despite using the right sources for the information, it persisted on presenting movie names that were movies from 2021. So you can kind of imagine the distrust and of course the hallucinations just make those issues top of mind and paramount for enterprise organizations, trying to bring this type of technology in-house. This, in fact, was in the news even with Google and their Gemini rollout when someone asked, the best way to stick cheese onto the pizza bread and pizza dough, and Gemini shot back, you have to use glue. So no surprise, that anxiety, there's a good reason for that anxiety. And the healthy skepticism is always good. And of course, we know now that as we engage and embark in some of these initiatives inside the large enterprises, there's a popular architectural pattern that's starting to take hold, especially in the context of what's called Retrieval-Augmented Generation, or RAG. And if you think about what RAG essentially is, it's essentially the ability for organizations to break down large text corpuses documents into sizable chunks that get indexed to help with retrieval, making the retrieval process easier, utilizing what's called vector-based semantic search, ultimately presenting the specific retrieved set of text chunks to the LLM to become then the final arbiter in terms of helping it reduce hallucinations with additional or better context. And that's great. The keywords here, emphasis on documents and reducing hallucinations. Of course, at this stage, many of you should already be further down in your own journeys. And for those that are just getting onboarded and learning, perhaps these limitations may give you a bit of pause before you consider going down a path and investing a lot of time. We do know that RAG implementations do have limitations. Number one, they're still very much limited to documents. So when it comes to asking questions of data that sits inside of your trusted sources, your proprietary data sources like databases or applications, RAG doesn't really help much. Number two, you saw the word reducing hallucinations. Now, reducing hallucinations, we all know, is not the same as eliminating hallucinations. Great. I have reduced the amount of hallucinations I generate by accessing information directly from the large language model, but ultimately, even after the RAG approach, where you're presenting it relevant context with chunked text, you still find that there's sufficient amount of hallucinations that might give you pause, especially in regulated industries, and the fact that you're still relying on the large language model to be the final arbiter. Third, we know that there are still challenges with dynamic knowledge. And what that means is, at this stage, we are still relying on information that's old, outdated, not real time, in order to answer a question. And the dynamic nature of enterprise data, it's always constantly changing. And then last, there's limited context, because the context still centers around this notion of nearest neighbor searches to the specific set of concepts that are referenced in a particular question. That helps me identify the right text. But what I don't have is this sort of deep cross-domain knowledge where data is dense and data exists across domains. And that connected nature of data, the relationship between data, is intrinsic and sometimes not picked up by these vector-based semantic approaches. And so those limitations certainly hinder your ability to provide accurate, contextually relevant information. Of course, it is no surprise then that Gartner has started to really call out in their own review of the technology landscape and what they find has been working well in terms of GenAI applications is the usage of AI and along with knowledge graphs. And the idea of knowledge graphs has been around for some time. You know, it started with the advent of evolution of search by Google. And to the extent that we're now in this universe where GenAI is becoming increasingly important to enabling your knowledge workers to answer questions about your business data, knowledge graphs really sort of shine because they deliver trusted and verified facts to the outputs that are needed in order to generate a response from large language models. And so being at this center of this bullseye means that this is a widely adopted pattern Gartner is beginning to recognize, talking to their growing use of enterprise organizations and members inside of those organizations. So why knowledge graphs? We know knowledge graphs are great at capturing business context, that cross-domain knowledge. And why it's especially important is because it's abstracted away from your data estate. So think about all the tables that are sitting inside and locked up inside of your enterprise systems, from data lakes, multiple data lakes, to data warehouses, multiple data warehouses, to applications, to multiple applications. and not fully recognizing the relationships across those domains, silos, across those data silos, across those application silos. And so by abstracting and modeling information in the way it needs to be understood and consumed in a knowledge graph, you are essentially establishing that cross-domain context that is important for the consumer, in this case, the GenAI application, to fully comprehend and understand in order to be in a position to accurately respond, and more importantly, to ground itself in enterprise truth. And so here's a very simplistic example of domains across customer systems, policy systems, claim systems being articulated in this right-hand image as the semantic data model representation of what information means to the business and the business use case that you're trying to enable, regardless of where the data sits, regardless of how the data is structured, and regardless of where the data is located. And that manifests itself in, across multiple industries. So you can think about cross-domain knowledge. What does that really mean? Here's an example of supply chain where there's a severe quality note for a fender burn associated with a particular vehicle VIN number. And that needs to trigger a stop shipment in the factory. And so the questions that you want to ask as the knowledge worker, as the frontline worker, what are all the quality notes associated with this particular vehicle? Was there a resolution for the quality notes that was logged? Was there material that was made up that impacted the component? Were those materials being shipped or supplied by one supplier or many suppliers? Are there orders actually currently in play that are potentially impacted? And so you can imagine in this scenario, you're now looking across multiple organizational, functional data silos, and this domain knowledge needs to be brought together quickly in order to respond and answer those questions. Same is true when you think about it from a pharmaceutical perspective, right? Drug repurposing. I am trying to study the interaction of a particular drug, oxytocin, related to autism, and see if there might be opportunities for a new drug, right? So what are the genetic conditions that are suitable to treating autism? What compounds actually have been tested in similar conditions with similar treatments? Is there a gene expression that can be used as a biomarker to understand if the drug that we're presenting is delivering the desired effect? Or which manufacturer supplied the raw ingredients, because I might want to look at an additional supply, and what other studies might be relevant to answering those questions? And again, you can imagine this sort of cross-domain, cross-application information that may not be readily available or connected in order to answer these questions. Same thing with financial services. I'm trying to understand if certain board members for companies are being investigated based on their relationship with the organizations that they sit on. And you can kind of understand, you want to understand the affiliation of these individuals, you want to understand the financial stake of these individuals. Maybe you want to understand what other companies are they connected with, where are those companies located, what are those transactions between those companies, between those individuals, are there subsidiaries, are there shell companies? That can really get complex. And again, information that comes from across systems, across functional areas in order to be visible and viable for someone to be able to answer deep domain, contextually relevant questions. And so knowledge graphs really start to address those limitations of RAG, and sometimes labeled as graph RAG, which is further reducing hallucinations, helping reason over connected data based on business logic versus reasoning that LLMs that tend to sound like they're reasoning over data, but really they're predicting based on probabilities of words. What's the next set of words that make sense based on the word that's in front of me? That's not quite reasoning over your data, over your enterprise data, based on your business logic. And then, of course, the knowledge graphs really shine when it comes to enhancing the accuracy of the answers, because they encapsulate that deep cross-domain business knowledge that's important to answering the questions that I just highlighted with some of the use cases above. With Stardog, we have taken an approach that brings all the benefits of a knowledge graph plus more. And so what is that plus more? And we call this notion of a safety RAG. Number one, it's a fully integrated, out-of-the-box experience for organizations that are trying to prove out GenAI use cases. And this fully integrated out-of-the-box experience comes with prescriptive industry use case-based ontologies or semantic models. So you don't have to start something from scratch. You can leverage these industry ontology models as a jumping off point to mapping out information against your data landscape and enabling GenAI application for your knowledge workers, frontline workers, to begin to ask natural language questions to, again, get natural language answers. Number two, the limitations of RAG is, and even graph RAG for that matter, is still focused on documents. And so Stardog, with its safety RAG approach, allows you to operate over both structured and unstructured data sources. And these could be data sources that are data lakes. These could be data sources that are data warehouses. This could be application data sources, semi-structured databases as well. And to that extent, we integrate over 150 plus data sources. And our approach is key here because one of the limitations of RAG, and even graph RAG for that matter, has always been the fact that you're still relying on point-in-time data, right? Now, data is dynamic, fast-changing at times, and we utilize this approach that is a hybrid approach, utilizing data virtualization, a combination of data virtualization and materialization, so that when we are answering the question, we are accessing the most up-to-date, dynamic, real-time information within your enterprise. And last but not least, and this is the critical point from a safety RAG perspective, is all answers are grounded based on the ontology of the model. And the final answer that is generated comes from your enterprise sources and not the large language model. And so what that means is we're eliminating hallucinations and ensuring there's trust with full traceability from where we got the answers. And that's a key differentiating factor, is that the reliance on large language model is not to generate the answer. In our case, and I'll talk through this in the demonstration as well, in our case, we're relying on the large language model that we have fine-tuned for our purposes to generate a structured query. And then we execute that query in a federated manner against your enterprise sources and get those answers directly from your enterprise sources in order to answer the question based on the grounding that comes from the ontology of the semantic model that I shared earlier. So what that allows you to do then is basically enable your knowledge workers to ask any question about any data and get timely, accurate, and explainable answers. And this is utilizing the combination of enterprise knowledge graphs and generative AI to deliver a powerful knowledge worker based chat interface to your enterprise data, where data is accurate, timely, secure, and hallucination free. And again, I'll showcase how this all comes along, but more importantly, what you need to know is that this, of course, for many companies is a journey. And so while you may not be ready to enable your knowledge workers with a natural language interface to start asking business questions of your enterprise data on day one, what's important for you to understand is that knowledge graphs and enterprise knowledge graphs from providers like Stardog specifically allow you to create this modern data foundation so that your data is GenAI ready, by essentially creating a flexible semantic data layer that sits between where your data lives and where your data gets consumed. It harmonizes data based on business meaning that's abstracted away from all your data estate. And it utilizes the benefit of this sort of ontological based concepts or informational models, business information models, to abstract and attach meaning to the data. And more importantly, it limits data sprawl. So you're not constantly moving data in order to answer and enable those questions that I shared with you earlier. You're leaving data at place. And so at query time, that computation gets pushed down to the source system if need be. from a federated data access perspective. And more importantly, you're now enabling your citizen data users to self-serve, and doing so with a foundation that facilitates reuse and sharing through open standards. And that's critical for you to understand. This is widely now adopted across many European companies and in very specific industries like public sector, where we're working very closely with the intelligence community as an example of the type of standards that we're trying to bring to improve data sharing across multiple agencies. And I know that's the same is true for organizations inside functional areas within an organization where they want to facilitate reuse and sharing through open standards. So this modern data foundation is sort of almost like a layup for what we're really trying to enable in the GenAI scenario, sort of this agent-based architecture that can then operate on that knowledge graph where a question gets asked and an answer gets produced, both in a natural language interaction perspective. We understand what part of the concepts that are being referenced in the question actually are referenced in the actual knowledge graph. And then we're able to generate a query, a structured query for that, and then look to your enterprise data sources in a federated manner to get the answers and present those answers or summarize those answers back to the user, or do further analysis on the data, or generate more charts, describe the entity itself. Or in our scenario, we're also leveraging the power of external LLMs so that there is an element of tapping into what is good out there sometimes, which is this broad general knowledge that still can be leveraged, perhaps in order to help the user do their job. Ultimately, it's about helping specific users in these industries with their jobs to be done, and giving them ultimate access and power to information, whether it's tapping into your knowledge sources inside the enterprise or general knowledge that's available as part of the value that we can bring with this sort of multi-agent orchestration. So what does it all look like? Well, let's dive right into it. I will give you a quick demonstration to kind of have some of these concepts, bring some of these concepts to life. I will also take a moment to see if there are any questions from anyone here that I can answer. Okay, let's see. We have a few questions. What are the most common scenarios where hallucinations occur in AI systems, and how can Stardog mitigate these risks? Hopefully, Lynn, with the slide where I see you started to ask that question at the beginning of my presentation, hopefully it's been made clear through the end of my presentation so far in terms of how Stardog takes a unique approach. What does the conceptual architecture look like, Robert? Hopefully you saw that in the last few slides. I'm happy to speak to it a little more broadly if you have more specific questions. Ultimately, like I said, we sit between your source systems and your consuming applications and providing a sort of a semantic data layer, whether it's an implementation of data mesh or data fabric. Many approaches have been, or data products. Those are typical ways that companies start to build this foundation with Stardog's knowledge graph approach. Question from Shrikant: do you have financial like banking system ontology map? The answer is yes. We can not only we've mapped a lot of different ontologies across different industries. Certainly a great way to jumpstart, like I said, your GenAI use cases and prove out those use cases quickly. I will talk about our approaches, and that might come across clearer when I start to demonstrate as well. How do you stop LLMs from hallucinating when it comes to generating the proper query? That's a good question as well, Harry. We use a combination of fine-tuning approaches for the large language model that we do utilize for our purposes from a query generation perspective. But we also have the ability to do self-correction. So it's a bit of an autonomous interaction that happens between our query engine and the large language model. When we see a response of a specific query that has errors, we have validation. We have validation steps in there. And then we ask a specific we send a specific response back asking for corrections to those validation errors. And so that interaction happens behind the scenes. All right. If using enterprise sources instead of the LLM to generate the answer, what is the enterprise? What if the enterprise is not in a user-friendly format? See loads of nested structured data when they expect a neat natural language sentence. Yeah, so I mean, look, some of this is some good UI magic. Other is just the way you want to break down the specific ontology or the data model that reflects information in those sources. There's a multitude of ways to do that. And I'll showcase and highlight some of those as well for you here as we go through the demonstration. What differentiates you from Neo4j and others, Robert? I mean, the big key difference here is that, as I mentioned, we're not taking a RAG-based approach, which is, first of all, focused on documents. Second of all, is leaving the ultimate LLM as the arbiter of the final answer. In our case, we can operate not only Rodota documents, but databases, structured databases, semi-structured databases. And then we ultimately rely on the enterprise sources as the source of truth for the answers that we present back to the user. And then more importantly, our federation approach allows us to leave data at source. So we're actually accessing real-time dynamic data versus Neo4j, which is a graph database where you actually have to physically copy move data before you can do anything, take any action. Hopefully that answers some of the questions specific to that. And then are you using multiple ontologies based on a general business, or does it need to be specific to the business and thus bespoke? Yes and yes, right? So we certainly can leverage industry ontologies that are relevant from a general business perspective. Every industry, every use case is very specific. And so the idea here is that we're trying to make this as focused from a benefit to the user perspective, and sometimes that might require some changes to the ontology or to be very specific. Sometimes adding reasoning logic that is specific to a user or a user use case that can also be annotated on top of the semantic model. I'll talk about that as well. So lots of good questions. I'm going to take a quick break here and get into the demonstration. I'll come back to the questions after the demonstration. Let me go ahead and share my desktop again. And there it is, sorry. All right, let's move to the demonstration part of this. So I will open up our Voicebox application here so we can go into a new chat. I'm taking a context of a healthcare scenario. This can be a supply chain. This can be a financial use case. As I mentioned, some of those examples I shared earlier. In this case, I have healthcare patient data where I'm looking at medical conditions performed during encounters with providers, with prescriptions and diagnosis and the treatments that have been administered. And as a healthcare professional, I'm trying to better understand the implications of and effects of certain medications. Perhaps I'm in preclinical, clinical R&D, and I need to better understand all of this. You can imagine a lot of this data sits across silos. And so the interaction here, this is sort of from a context of our user interface. Obviously, there's an API behind this if you want to embed this within your own applications. So maybe as a user, I can start off with some preset questions that are important to me, things like list the years of how many procedures were performed in that year in decreasing order. And you can see immediately we come back with a response. There's 35 years of recording procedures. You see the listing of the year and the procedures. I can review this data in a sort of table-like structure if I wanted to do that. What's also interesting is when I came back with the answer, I have the ability to kind of see, let me move this here, explain the response. I can see that procedure was performed, and I can see the structured query behind it that was generated. And this allows me to then see the source of the information from which I was able to pull this data from. So that's part of the query generation piece that it runs behind the scenes. I may want to turn this into a bar chart. And again, the idea here is that I can not only look at table data, but I can look at sort of more visual information presented to me. Now, of course, there's a lot of data here. So if I wanted to analyze trends, I can kind of look at those as well and say, okay, well, what is the data really telling me? Help me with the analysis based on this data set. I can see that there's general trends around data either significantly increasing the number of procedures performed. Obviously, that's visually evident in the chart here, but you can kind of see this is sorted in the order of the year of number of procedures. And so that analysis is now presented back to me here. And then, of course, I can also utilize multiple agents that sit behind this to run computation, more complex computations, to compute the total procedures performed and its standard deviation. And again, here I'm leveraging the power of certain language models that are better at mathematical statistical operations. You can kind of see I've been able to come back with a response from the total procedures and the specific standard deviation. Now from here, I may want to ask a question like, which was the most prescribed, or which medication was prescribed the most, right? I mean, so there's multiple ways. The idea here is I want to understand, which medication was prescribed the most, so I can kind of ask that question. And when I do that, I'm also looking at the dynamic prompts that get generated that I may want to ask more questions. But you can also see the interpretation. I just said which medication was prescribed the most. It kind of came back and interpreted it to be which medication was prescribed the most from 1971 to 2019. So it has that multi-turn conversational context from my previous set of questions to understand what needs to be applied in order to answer the question. You can kind of see that it actually came back with the specific information about the medication with total 219 subscriptions. And these hyperlinks represent information that I'm actually pulling back from my enterprise data sources. And I can kind of look at that, in sort of a graph-based view here. And I can see everything associated with that particular medication in terms of diagnosis, prescriptions, encounters, conditions, et cetera. And that information, I can see more details about the specific treatments and when they were highlighted, and I can see what else it tells me about the predictions. So if I have ML models that are attached to this specific medication, I can kind of look at what those predictions are telling me for the types of conditions that are associated with that medication as well. That's part of my larger knowledge graph. I can also continue the conversation from that full page experience, but I'll kind of go back to the full page experience for now. And in here, I can kind of also leverage some of this external knowledge base as well, right? So if I say, what are the side effects of Smith's, and I can type, so I'm just going to copy this here. Medication here. One of the important elements of this for us is, when do we know not to answer a question, right? This is the part of the no hallucination. So, we came back with cannot find an answer, not partly, 100% because this information was not grounded in the semantic model and it was not mapped to an enterprise data source. And so we will always err on the side of we cannot find an answer to this question. But if we wanted to leverage the external knowledge base of a given large language model that the organization is using, or you want to leverage a third party or a Llama 3.1, doesn't really matter. We have the ability to configure access to this external knowledge base. So again, from a user perspective, they get the information they want, with the caveat that, we remind them that this is unverifiable data. It can still contain hallucinations, but at least they have information that they can use some judgment to say, yes, I can understand the side effects of that medication in this particular context. I can say, who are the patients that were prescribed that medication. And again, from here, I can generate, perhaps a very specific, say, again, I can't answer the question, but if I wanted to look and say, okay, show me the specific employees or people that were diagnosed with this particular medication. Maybe I want to look at a very specific individual and see if that answers the question that I'm seeking. All of that is prompted by really what sits behind this is the semantic model. The semantic model here, and I'll open the healthcare one, is you could kind of see the patient data, provider data, specialty data, organizational data, diagnosis data, encounter data, prescriptions, procedures. We have built a semantic model. And then this information is mapped back to the source of the information. So when I pull patient data in, like I did with Ebony, I can kind of pull back and see that this data actually is being pulled from my Delta Lake table in Databricks. This could also be attached to a whole variety of sources, from Snowflake to Synapse to Salesforce, Postgres. All of that can be mapped here, and the information is federated at query time. We push compute down to that system in order to answer the question. Now, certain sources don't lend themselves for real-time querying. We have the ability to materialize information as well, either in our caching layer or in our storage layer, if that needs to happen as well. And so in this hybrid approach, you can access data that's fast changing directly at the source. You can pull, say, move static data information into our storage layer for materialization. And this can be across multiple domains, right? This is one context around supply chain. You can kind of see that we have supply chain data about distributors and trucks and sensors, selling points, finished products, production outputs, and we've mapped that data to different environments, Snowflake, the Databricks. We have customer information, in this case, coming from Snowflake. And then we have sensor data that we're pulling in from Databricks because that's fast changing, perhaps. We have data mapped to some file system. So this is, again, a variety of ways you can encapsulate domain knowledge as part of your grounding of the large language model. And when a question comes in, we identify parts of the semantic model we need, and those relationships within those entities that we need to understand to generate the query for us. And then we push the compute down from a federated data access against your source systems, and then summarize that answers back. Now, what's also important in the value of the knowledge graph on top of the semantic model is the fact that you can reason over your enterprise data, and that could be applied based on your business logic, right? So one of the things I want to talk about when I talk about anomalies is that anomaly is not a concept that exists inside of your enterprise data, but a business logic can be applied, and the data and the information can be reasoned over the data. So when a sensor has an output as part of a temperature reading that's being monitored on a truck with a value of greater than 45 degrees Fahrenheit, and then you can infer that truck has an anomaly, and that sensor output can be classified as anomaly. So you can add business logic that's relevant to your user or use cases, and this can vary by user. The definition of supplier might change, perhaps. You want to add those. And again, these can be annotated on top of the semantic model and executed at the time I'm asking those questions that I was showing you earlier. All right, I'm sure that has generated lots of questions. So let's take a quick look at where we are. Ooh, lots of questions. Okay, I will try my best to answer these questions. And this is actually coming in the chat interface. Let me stop sharing here. Or maybe they're in the Q&A as well. And possible returning personal information, is it possible to limit the data that can be returned based on the user? That is absolutely correct. We follow full RBAC, ABAC controls. Data can be obfuscated at a finer grain level. So like a social security number can be hashed out, or a phone number can be hashed out. And that can be based on groups or roles of people that are either part of the Stardog system. We can also take your roles as you've described them in your own identity providers like Entra ID from Azure. Hopefully that answers your question. Jonathan, Robert, only a SaaS solution available, or is there no on-prem option? Yes, there is both a SaaS and an on-prem option for customers. please reach out. Happy to talk through that with you as well. Our fully managed solution sits on AWS, but we have a VPC option that's available on all major cloud providers. We're a Dockerized Kubernetes-based system, so you can deploy in any of those environments. Let's see, coming back to the previous question, string procedures, was there hard-coded NLG output template for each attribute? Hopefully some of this was answered through the demonstration. But if I only have one data source, why would a knowledge graph be better than my own prompt describing my data model? Harry, that's a good question. I would say, this is where I would say, if you have only one data source and your types of questions don't really require complex joins at the back end, you're probably good with what you have, right? But if your types of questions that you're generating or your user is generating require complex joins across tables, even within a single data source, then knowledge graphs are pertinent. More importantly, what it also does is it enables you to encapsulate enterprise knowledge at the semantic layer or knowledge graph level. And so tomorrow, if you wanted to switch sources, you don't have to necessarily retrain, recreate, reprompt data based on that source in the way that data is structured, or how you model information there. Because remember, the idea of the semantic model is you're adding new meaning attached to that data. You're enriching through semantics, creating, inferring new knowledge. And so those semantic concepts may not necessarily exist in your data model. So as an example, I would say that I'm a member of the royal family, and I have a parent-child relationship to the prince, and the prince has the relationship to the king, and a parent-child relationship. And that's evident in my data model, that's evident in my data. But what's not evident is the cousin relationship, the sibling relationship, the aunt and the uncle and the grandparent relationship. That's something you can semantically enrich within your semantic model without having to rewire your data model, which was, again, designed for fast coefficient querying, perhaps, or modeling and structuring data for fast and querying, not necessarily capturing that complex knowledge that is needed. Hopefully, Harry, that answers your question. I see the questions have moved over to the chat. How can I learn about Stardog? There's lots of information. In fact, that's let me transition to that here, and I'll come back to more questions for this group. Back to my webinar slides, share mode. Okay. How do I get more information about Stardog, which was the question that was asked? First, for those that are interested in figuring out ways to bring rapid value around GenAI and GenAI use cases, we have a very methodical approach to enabling this for you, and what we call a 0 to 8 week engagement. We offer both fully hosted and a managed service on AWS or on-prem that can be implemented in 8 weeks. And we typically connect up to 5 enterprise data sources. So everything from knowledge engineering that requires discovery of data, connecting, mapping data, to building out the data model or leveraging an existing model and making sure that it fits to your needs, which is part of the refinement of the model. And then there's a test period by your users in order to ensure that the information, the answers that are coming back are accurate and good. And then we can roll this out to a larger set of user community within your organization. But if you do want to get started, there is an experience for you for free. Go to stardog.com/cloud, and you will see that journey for you through a free endpoint. You can experience the same demonstration that I just gave you within that free endpoint across multiple industries. And then, of course, whenever you're ready for us to engage with you, just give us a call or reach out and connect. And just on that topic of getting started, this is where you kind of go, and we have these industry knowledge packs with various industry models that you can utilize to kind of experience some of this based on the specific industry that you have. All right, I think that is the end of the session. I will see if there are more questions that got generated. In the meantime, I see that there was, are you using embeddings for semantic search? We are, as a part of the semantic search, we are using it to identify the key parts of the ontology. So the semantic search is against the question interpretation against the specific ontological concepts in the data model itself. And that's all wired and built and integrated within the product. We should be announcing a gift as well, if I'm not mistaken. The winner is, yes, Cindy from Citigroup. Thank you. Jazz, it's a $100 Amazon gift card on its way to you, Cindy. We appreciate you attending, and we do appreciate everyone attending the session. I will take a few more minutes to answer questions if you want to hang around here for a little bit. And let's see if there's anything I missed. Have you encountered misinformation, risk in your implementations? None so far, Vijay. Again, the idea here is to eliminate hallucinations by grounding everything against the ontology. So when I ask the question, show me the side effects, it does not have that information, and hence it will not give you an answer. Versus a large language model by design is expected to give you an answer always, and sometimes in ways that sounds very authoritative when it's clearly not. What kind of LLMs? So we continuously fine tune large language models. We leverage open source. We've leveraged Llama 3.1. We continue to look at others out there in the industry, and continue to evaluate on your behalf the best model to generate the best accurate responses. What ontologies do you have for healthcare? Again, I shared an example of that. If you check out our Stardog.cloud free endpoint, you'll see access to some of those models for healthcare as well. And that can be explored in your sandbox. Does Stardog provide functionality with VectorDB? Like I said, we do have an embedded VectorDB or vector search approach as part of the initial identification of specific ontology concepts to your questions. Let's see what else is Stardog product. If one has RDF ontology model, yes, you guys can use an existing ontology model from an RDF construct and bring that into Stardog. Stardog is itself a RDF-based system, and it's our own proprietary developed standards-based graph technology based on RDF. Are you using single or multiple ontologies? I think I spoke about that earlier. So I think I'm caught up on the question and answering. Again, if I missed answering any questions, do we work with DoD or other cleared environments? Absolutely, we do. Please reach out to us, and we can share with you a lot more details about our footprint in the DoD space. Again, thank you very much. Is your health-related demo on your Stardog website? It absolutely is. Data fabric, data mesh, which is good in data virtualization. Honestly, data mesh more so than data fabric, but both have fundamentally benefits of utilizing the power of virtualization. So again, thank you for your attention, and I will let you guys be on your way and go about your day, and appreciate everyone listening and attending intently. So thank you again.